Hi everyone. We're going to be talking about FileIO and input and output in general. That's what I/O stands for, not the Google conference. And so when we're going to be talking about this, I'll be breaking this into a couple of parts. I want to make sure that, well, first of all, I need to find my pen. Sorry about whacking the microphone if you heard a big bang. We're going to be talking about printf statements, SCANF, getS, or gets as everyone seems to call it around here, fgetS, and a couple of other things. Right now I'm actually installing an update to my Visual Studio, so hopefully that'll go fine, but I may have to pause the video when looking at that. So let's get going. So we've been sort of glazing over some of these details, and I appreciate if it was a little stressful using some function we haven't even talked about, like printf. I want to look at C-specific functions, so we're not using cin and cout, although I have left those slides at the end in case you want to look at them. We will be going over those in a lot more detail when we hit bit 2400. So in case you wondered, why are we not learning C and cout? It's because they're not C. Again, they're C++. But I left them in just in case you want to have a look. So what are we doing? Well, we are trying to essentially take information from our program, put it out to the console window. Pretty much every language I can think of, at least, has some means of outputting to the user, because it's critically important for when debugging. I don't know if I have the quote in here, or if I have some. I think it was in one of the earlier lectures, talking about there's no substitute for carefully considering your code and a generous number of printf statements. This is one of our ways of figuring out or deducing if our program is working correctly. Printf statements are not what every function has, but they are a very critical tool for us trying to figure out how our function is actually running. So we may have something like to be or not to be as a printf statement, and it goes from the program out to the console window and is displayed on the screen. That's our set of input and output functions. We can also have someone type in something from the console window and have it go into our program. We can have code going from into our program directly in our main method. That's one of our 3 different forms of main methods. We'll look at that in the lab, where we have a bunch of inputs, parameters going into our initial function call. So we are going to predominantly look at things like printf and scanf, and then we'll look at file printf and file scanf. So fprintf, fscanf after that. And I'd like to point out a couple of little things. One of the big things is white spaces are some of those things that confuse a lot of people. We have things, we have special characters, because there's no real way for me to type in a tab, or especially type in the enter key. If I actually push the enter key, it actually puts it on a new line. I may want to have something like various spaces, new lines, tab, vertical tabs, that sort of thing. And I want special characters to be able to do that. We looked briefly at those in when we're looking at strings. We even talked about the fact, if I'm remembering correctly, that how do you do a backslash, which is this thing right here. This is the backslash right here. How do you do a backslash? Well, you put 2 backslashes, one after the other, and that'll give you a backslash. We need some kind of escape character. Some way of saying, oh, flag on the field, there's something important coming. It's a new line. It's a /n. It's a new line. That is considered one character. That's /n. It's one character. It is one ASCII value. I just need 2 characters to represent it. Same with /t, /v. And those are important because functions like scanf actually go until you get to a white space, until you get either a tab, a space, a new line, whatever the case is, and that's when they stop. If I'm using getS, which we'll get to in a very soon, get user input. Okay, when we use getS, it will go until it gets a new line character, not any old space. It has to be a new line character. And so these are ways in which you sort of have to know what's going on under the hood in order for things to work out correctly. So, that was not supposed to have done this. So first of all, if you ever want to look it up, there's plenty of online resources. This c++.com, great little resource. You're not going to, if we open this up, you will see like 4 pages of all the different parameters and things you can do with a printf statement You're not supposed to memorize that. You're not supposed to necessarily remember them. You're supposed to, when you need them, look it up. The worst thing you do is try and memorize all this stuff. We want you to play with it at first, help cement it in your head. But we don't want you to memorize and remember all the various syntax for printf statements. It's useless. It's a waste of your time. Put it on your cheat sheet if you want. That's fine. But I will not ask an exam question saying, okay, do this printf statement and make sure that there's exactly 2 spaces here. People can look it up. That's the point. I can ask for that in an assignment. I can ask for it in an exam, but I can't put a lot of points on that. The points will be how you think through the problem, the algorithmic thinking. Okay, so we'll look at something like this in a second when I finally get my Visual Studio up and running again. Something weird happened. A student sent an assignment question that seemed to have a virus in it, which may have given me a virus. I'm not sure, so I'm checking that out. In case you're wondering why it's offline right now. We have 3 different kinds of print statements, at least the 3 simplest forms of printf statements. We have printf, which outputs to the console. We have sprintf or sprintf. No, it's sprintf. Sprintf outputs it to a string. It outputs it to another character array. So I'll have a message like hello. There's like message right here. Hopefully, if you can see let me move my mouse. There you go. Like this message here. It's going to have hello Joe ID 1234, right? It takes the first parameter here and takes the first parameter here, which is also a string to a string, right? This is going to put a string. That's what the %s says. And here's my string. The %i says put an integer here. Here's my integer, the second parameter. The parameters go in order. So parameter 0, let's use 0, to this first percentage. And then parameter 1 to this one. It will compose this string, and then it will dump it into this character array. When we looked at character arrays last time, I'm going to pretend I have a character array called a destination buffer, and I'm just going to throw all those characters into that a destination buffer. I think sprintf will also have a _s version of it, which will also say the size of my destination buffer. And if I don't have that, it could go over the limit. If a destination buffer is size 4, let's say, it's going to clearly go past that size. Okay. Printf doesn't need that because it can put all of this out. It's just putting it all out to the console window. What you'll notice, though, is it also returns the number of characters its output. So I can figure out, did this work correctly, for example? So here's my student name, here's my student ID, hello, Bob, ID 1234, and that will go, it will be however many characters this is. So 1, 2, 3, 4, 5, 6, Bob 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 with the /n. Or when we get to later, we're going to have fprintf, as in it will go to a file. So here's my string, and it goes to a file, my file. And again, it says how many characters were output. That character's output is really handy, because if I have something like a string and I want to make sure it's the right number, I could actually count up the size of the string, or I could call string length on various strings to make sure it works. It was meant to be these both showing up at the same time, in case you're wondering. Output precision, when we output this, we have a bunch of different parameters we can use, a bunch of different things we can control. And much like that /n, if I go percentage and then other stuff afterwards until I get to one of my ways of outputting it, like a D for a digit or an F for a float, I can have things like this should be 8 characters in total, 2 after the decimal point. I'll have to look into that. I don't remember all of these parameters. I do know that this dash will allow me to have plus will allow me to have positive and negative values, and the dash does dashes up until the point of however many characters I'm going to do. So this should be, I do believe, 9 dashes, and then be 5 digits, whatever that digit is, and there'll be 10 in total. Oh, no, let me see. Value 10, up to 10 decimal points, so it'll be 3 dashes and then 1 0. I don't remember these things off the top of my head. I look them up when I need them. We'll play with those in a second. I'd also like to point out that Visual Studio and a lot of these other things are annoying because despite the fact I'm going to be talking about SCANF, printf, fprintf, fopen, all these things, most of them require an _s for safe or secure. And the reason is because they should have always had that, quite frankly. If I have an array, I'm outputting things to, let's go back one. If I'm outputting to a destination buffer, and I do not know how big that buffer is, and this string here ends up being huge, what happens? I put values in my buffer, and then I go past that line and keep going. There's nothing in C that prevents me from putting too many characters in there and stomping on random memory. That's bad. So hence we have these safe versions of the file of these functions. Okay. For input, and we'll talk about SCANF. Now we really should be using SCANF _s, or you might have to work around it other ways. If you don't have SCANF _s, see if you can make sure you have it as well. The TA should definitely have it. SCANF will say take in some kind of input, and this is defining what kind of format it is, and then afterwards it's each of the different inputs coming in. So I'll give a couple examples in a second, and then it's going to return an integer. So it's going to get information from the console. It should also say what goes in, so it can have white space, and it should, let me see here, this should be the number of characters filled in, or the number of, I want to look at this actually myself. It should be the number of characters typed in for SCANF, but I want to double check that sort of thing. These are the niceties to have when you're doing this. So here would be a good example. Let me predicate this. I don't think it's a great example. There's a reason, because I never put 2 inputs in a row, ever. I just make it a habit of mine not to do that. Why? Because I'm going to have a real hell of a time trying to figure out what's wrong with my code if I put in 2 inputs immediately one after the other. If I do one input and then another input with, what is your name? What is your ID? As 2 separate inputs, it's a lot easier to debug. It's a lot easier for the user to know what's going on. Okay, here would be a bad example, by the way, right? I'm not allowed to have anything other than white space and the input symbols. So this is a big no-no. Can't do it, not allowed. Same thing here. This will not work. It'll actually barf on you. You'll also notice one other thing. We'll get to this very, very shortly. That and, the ampersand, if you will. We'll be looking at this very soon when we look at memory and we look at pointers. And you'll see it again, and I'll remind you again of what it is. If I have a string, if I have a character array, I can just put in the character array. If I have something like an integer that I'm storing, just a basic variable type, not an array, I need this and symbol. And there's a reason for that, but we'll get to it later. So if it's basic data types, I'll put an and. If it's a string, I don't need the and. How about this one? What's wrong with this? Well, this is taking in a string and then an integer, and now I have a pointer to an integer and a pointer to a string. I'm not actually sure what this is going to do. I'd actually have to run the code. What I would hope it would do would be yell at me because the parameters don't match. I have a string and an integer, then an integer, and then a string. But I have a sneaky feeling if you try and type it, it says, okay, thank you very much, and then pretends that this thing here is a string and pretends this thing here is a pointer to an integer, and bad stuff will happen. So it's very easy to accidentally flip around your parameters. Another reason why you want to do one parameter at a time, one variable at a time. At least that's my personal opinion. Okay. In case you're wondering, scanf _s, We'll also look at getS in a second, but scanf underscore s takes in what's coming in. This is it. So I'm going to get the user's input. They're going to type in some message. It's going to go into this array, myBuff, and the size of my buff is size 20. I normally side on the side of caution because I don't remember always. I will always say it can take one character less than the total size of my array, because I need that 0 at the end, that /0 at the end. So now I normally would leave off the /0 space that I need to reserve just in case. But maybe that's being paranoid. Love it to find out one way or the other if and I also need to do this. New line. I screwed that up. Boop, boop. There you go. Get or getS or gets will take in text. It's very similar to scanf underscore s. It will take in text until it gets to a new line. And there's lots of documentation for this. It's all over the place. Here's just one good source of documentation. It will just keep on getting characters until you press enter. So if I need a string like I am the very model of a modern major general, that's one line. I have spaces all in between there. I need to make sure that the spaces are still counted. I cannot use SCANF. It doesn't. As soon as I get to a space, it's another parameter coming in. So if I want a string including spaces, I need getS. So getS will simply just take in a buffer. GetS underscore s takes in the buffer and the size of the buffer. This one's perhaps the most dangerous of all of them. If I don't have the size of the array, it's ridiculously easy to overflow your array. It'll happen almost every time, right? I need to guess how long this array has to be in order to take a full line of text, and that could be anything. I didn't say how many characters I'm allowing. So getS allows you to take in a line. SCANF takes in a word, if you will, and stops as soon as it gets to white space. Unlike getS, which will take in a line of text no matter what, this could take in an integer, it could take in a number, it can take in a float, it could take in a whatever the case is. So those are my standard console input and output parameter function calls. Let's get to the more fun one. File input and output. Now, we normally have 3 steps to do this. First step, we open the file. I know, crazy. We open the file for either reading or writing or both. That's what we're leaving it to right now. But there are more things you can do than that. But normally we say reading or writing in this class at least. Afterwards, then we access the file itself. The opening of the file doesn't mean you're doing anything with it. It just means you're opening it. It's like pulling the book from the bookshelf and maybe opening it up, I guess. You're not reading the book. Accessing the files, reading the book. Line by line, I go line by line, I get, or part by part as I go. So I am reading the book, and after I've read one part, I move to the next part, and then I move to the next part. Every time I call fgetS, every time I call fscanf, any of these functions, I just move to the next part of my book. I don't read the same part over and over and over again. I don't have to move where I'm pointing to. It's a stream, and we'll look at this in a second. But it means after I've read it one part, the next time I call fgetS or next time I call fscanf, I will get the next chunk of text or the next number. And after I'm all said and done, I don't want to think of this as an optional thing. I think it's absolutely mandatory. You close the file. You put the book back on the bookshelf. You don't rely on other people to clean up after you. You clean up after yourself. So you close the file. But those are our basic 3 steps. Open, get access to it, close it. So fgetS, what I would normally do is every time I call fgetS, I want to check to see if fgetS will return something. It will return it should be either the file pointer itself or null if something can't be read. So instead of, so I can say if fgetS this, and it will that statement will be false or null if there's no other text to be read off the file. Okay, so I can fgetS will return null if, and we'll look at null very, very soon when we're talking about pointers, but fgetS will return this thing called null, all uppercase null, if there's no more things to be read. That means it's pointing to nothing. It's the end of the file, null. Okay. So I wanted to clarify what we're going to be doing in one of the assignments. What we're going to be doing is we're going to be opening up a file. We're going to be reading in a line of text from the file. We're then going to take that text, process it in some way, so pull off the various parts of that string of text. You could have also used SCANF if you want to. So after I've read off all those parts of the string, then it should be reading in classes that you've taken for each individual student. And I think it's also whether you're ready to graduate. I still have to plan that a little bit. So you'll read in the file, open the file, read in lines from the file, close the file after you're done. And then afterwards, now you have a string, and you can parse the string in various ways. That's going to make you review printf, sprintf potentially, and fprintf. So reading in from, so I can also write to the file as well. That's what fprintf will do. So we're going to go over an example very, very soon. A live example of how this code is actually going to work, especially if my wife's not too loud. I don't know if you guys can hear her on the other side, doing a meeting at the same time. But I want to look briefly, before we get into this, the difference between absolute and relative file paths. Now, I always assume everyone's already seen this, but it turns out people haven't, so if you're a little confused, that's okay. But I also want to talk about the file opening and what a file stream is first. So, much like a stream, like a river stream, a file stream is sort of analogous. If I'm in the middle of a stream, the water passes by me, I can't get the water again, right? It's just this continuous flow of water. With a file stream, as soon as I've dealt with one part of the text, I'm on to the next part. I don't go back to the old text. It's just this continuous flow of information at me. So every time I read or write, I move on to the next part. I open the file, I determine if I'm reading or writing when I open it, and every time I read some text, I'll move on further in my file. Every time I write some text, I move further into the file. That's what a file stream is. It normally requires me to have standard I/O in there, to include standard I/O in order for it to make this thing work. And so I'll have something like file, and we'll talk about what this is. This is a pointer to a file called my file, and then I'm going to open it. I'm going to put the file name and the mode for opening it. We have a secure version of fopen that I'll be showing you soon that will require the file, my file, being inside of the function itself. I'll show you that in the live coding. But before I get going, when I open the file, I need to make sure that that file is not null. This my file is not equal to null. If it is, I'm in trouble. It means I didn't open the file correctly. And if I didn't open the file correctly, stop, generally, right? If it can't find the file, it'll return null. My file will be equal to null, and I just stop what I'm doing. If I'm writing a file, I will make a brand new file wherever I said it was supposed to be, even if I don't think it's supposed to be there. And so wackiness can ensue. So we're going to be using a bunch of these things, and we're looking at this very, very soon. But after you read characters, you get to the next character, and that's what the big thing I want to point out. Okay, we're going to look at live coding, but I want to look at absolute and relative file paths. So first, here's a relative file path. If I do not have like C:/ or something like this, if I have my current state, or the ... means go back one. Do I have this in the thing? I don't think I do. ... If you've done the labs and you did the command line version of running code, you have seen this. cd ... go back one directory. Change directory, go back up one directory. cd, and then the name of the directory, you go into a directory. Just dot means the current directory. And I can make where this my text is, this thing will say, okay, so my text.txt, if I say that this is the name of the file, this is the file path, it means wherever I currently am, wherever the executable currently is, look for some file named mytext.txt. If looks like this right here, it means wherever I currently am, go back up one directory, go back up another directory, so go up 2 directories, and look for a file called mytext.txt. Great. That's a relative file path. These two are both relative. This just means the current directory. This is 2 directories up. And this says, forget where we are now, go to your C drive, which is your hard drive for most Windows users, right? And then go into a directory called temp, then go in, then look for myfile.txt. That's an absolute file path. You might think absolute file paths are safer, but both of these cases, it can be downright dangerous because you need to know where your code is being executed for a relative file path. But for an absolute file path, I need to make sure that somebody has something called, c:temp in the directory. Otherwise, it won't find anything. So if I'm making a video game, for example, and I want to know where that image file is, I don't want an absolute file path. That game could have been installed anywhere on the system. Absolute file path won't work. It would have to be where my executable is, and I'm in control of my own folder where all the game information is, and so I can say, okay, it's 2 directories up and 2 directories down, or something like that. The directory itself, the path here, might be optional, but the file name is not. I cannot open a file that does not actually exist. Okay, and if the file does not exist, again, I will get this null. And I'll have to figure out what the heck that actually, like, I'll have to figure out why that file does not exist, because that's what the null means. It's, I can't open it, or I can't look at it, or I can't find it. Bad stuff happened. Either stop, or at least tell the user that the file couldn't be opened. Okay. When we come back next time, I'm going to do some live coding of FileIO, some printf statements, and generally having a look at how all of this comes together. Okay? So thank you very much for listening, everyone, and I will talk to you shortly, especially if my Visual Studio is up and running. Thanks. Bye.